5,
4,
3,
2,
1,
go.
Hello and welcome to Space Now, the space news podcast from the National Space Centre that goes beyond the headlines. I'm David Southworth.
And I'm Dhara Patel.
We're science communicators here at the National Space Centre, and today we're back with another Mailbag episode where we'll be trying to answer your questions. Once again, we've not seen the questions in advance, so we're keeping our fingers crossed that we can give you some decent answers. But first, let's start with our space wows. Now, this week, for the first time in this podcast, we've both picked the same one, and we were both so desperate to talk about it, we thought we would just cover one space wow. Dhara, you tried to get it first, so I'm going to let you introduce it.
Okay, so I'm glad that you are equally as excited about this
Absolutely.
as I am. So today, as we're recording this, we had the announcement that the Vera Rubin Observatory has released its very first images. And I think both you and I talked just very briefly about how stunned we are with the quality of those images.
Really beautiful images. Amazing.
So anyone that doesn't know about the Vera Rubin Observatory, this is a ground-based telescope that has been in construction since 2015, so it's been quite a few years. It's basically situated at the top of the mountains in Chile. It's high, it's dry, and it's dark.
Yeah.
And that's where we want our telescopes to be to get the best views. It's looking in mostly visible light. So the light that we see with our eyes, but also with a bit of ultraviolet and a little bit of infrared, which gives it this scope to be able to see a few other things in space and create what we call composite images.
Yes.
So packing different bits of light together. And it's got on it, I guess, the world's best camera.
I heard it described as the world's largest digital camera. I think they're probably the same thing, aren't they?
Yeah.
Enormous.
I just, like, when you look at the numbers in this, so it's a 3,200 megapixel camera. And
we're not looking at the same website for our research, because I saw it as 3.2 gigapixels. Same thing.
Yes,
expressed
just different
differently.
ways.
So what's that, kind of 500 times the pixels on a regular phone camera, a decent phone camera?
Pretty much. So thinking about like your phones, or maybe like I've been looking at like TV screens. So a lot of us are used to like 4K ultra high definition TVs, and the resolution on that is about 8 megapixels.
Yes.
So you're talking about something that essentially you would have to have like 400 of these like 4K ultra high definition TVs all working together to produce one image, and that's what Vera Rubin can do.
Incredible.
Like, it's just like mind-boggling, the resolution it has.
And this is, I find, one of the things I find really interesting about this observatory, this telescope, is it's doing quite different things from James Webb. We're quite often used to talking about the James Webb Space Telescope and the amazing discoveries of the distant parts of the universe, the early parts of the universe. This is going to be looking for different things, isn't it? So because it's taking that kind of the full sky image from the part of the southern hemisphere where it's located, I think it's repeating that every 3 or 4 days. So it's going to build this enormous composite image you talked about, but it's then able to automate comparing images of exactly the same part of the sky over a few days later and a few days after that, and I think it's automatically picking out differences for astronomers to take a closer look at.
Yeah, I don't think it's necessarily something that has been done before. And when we've talked about whether we've done it on a podcast previously or not, things like the discovery of Pluto, where they compared like graphic plates to see like a point moving across the sky, to see that that's an object, not a distant star, but something closer in our solar system. The Vera Rubin Observatory is going to be able to do that automated, essentially. So astronomers are not there having to look at one picture and the next and then decide, or has something moved in these pictures, but actually night on night it will be able to track those motions.
So the really kind of laborious grunt work of spotting the differences is all automated, and then astronomers can take a closer look. We certainly did talk about it on a previous podcast. Josh and I talked about the search for Planet X and also the new moons of Saturn that have been discovered, and we talked about this kind of approach. So
speaking about Planet X, they've actually said, so scientists have actually talked about the idea that because of the resolution and the ability of this observatory or telescope, if there is a Planet X, they should be able to find it within the first year of operation.
That's incredible.
Which is, it's really exciting. And, you know, very briefly, again, we talked about just before the podcast started and we started recording this idea that, you know, lots of people often, like, coming up to Christmas, ask, you know, I want a telescope for Christmas. And it's a minefield. Like, what do you pick? And it's the same in an astronomer's world. You've got the Hubble Space Telescope, you've got the James Webb Space Telescope. Like, these telescopes within themselves are brilliant. They all have their specific individual niches, what they're really good at. But if you want an all-round telescope that is capable of doing lots of different things and lots of different things well, that's what the Vera Rubin Observatory is.
It's going to be perfect for that, isn't it? Well, as you can probably tell, we are both very excited about this. There are some beautiful images available already. By the time this goes out, maybe quite a few more. As we're recording this, there is a press conference going on, I think, as we speak, that's releasing more images.
They've said there's going to be additional images, videos, and a look at the capabilities of its time-lapse. So because it's taking these pictures over again, we should be able to see how the sky's actually changing over 10 years.
Excellent. So yeah, do keep a lookout for those, and maybe you'll be as excited as we are about this. Okay, so on to our mailbag. Once again, we have randomised questions. Dhara, you excited?
A little bit excited and nervous. I'm excited to see what the questions are. But yeah, let's get into it.
Let's do it. Well, we'll take it in turns. I'll try the first one. So we've got some randomised here, as I say, folded up. Okay. Do you get space litter anywhere that is not in the Earth's orbit? Interesting. That's from Molly.
It's a very interesting question. Now, I assume by space litter, we're talking about this idea of space debris, right?
Yeah.
So leftover pieces of whether it's like defunct or unused satellites, whether it's from objects that we've sent up, artificial satellites that have collided and kind of made different pieces.
Yep.
I think a lot of those pieces we would find in Earth orbit.
And plenty of those drop out of Earth orbit and,
Yes,
and
so
deorbit down to the Earth, don't they?
Yeah, my mind is going to, loads of them are in Earth orbit, but actually more so now, I think possibly because of the idea that, reporting is becoming more prominent, that we're learning about, spacecraft and objects perhaps not always landing in the ocean where we want them to. So there's a place called Point Nemo.
In the Pacific.
Middle of the Pacific, the spacecraft cemetery. So if you're going to deorbit a spacecraft or get it to come back to the Earth, that's where we want to land it.
Yeah.
As far away from anything inhabited as possible. But I'm sure I've read somewhere in, Asia, there was a part of either a Chinese or a SpaceX kind of stage of a rocket that landed down. It didn't injure anyone, but the fact that we have, bits of spacecraft, bits of rockets that actually can come down, the simple answer to that is yes.
Although
space
I think
litter
we're
does
talking
exist
in space beyond Earth's orbit. So we've also got things like the graveyard orbit, I think we call it, where we put defunct satellites if we're keeping them orbiting. But do we have spacecraft? Well, we have spacecraft still flying through space, but I guess they're still functional.
Yeah.
Do we have spacecraft orbiting other planets? Because we've put things in orbit around other planets. Are any of those still there, but not operating? Or have they all crashed down?
Yeah, so I'm thinking more so about things like Jupiter and Saturn.
Yeah.
So these huge gas planets that have had like multiple missions to them. So Saturn, for example, the Cassini mission, one of the legacy lasting missions of Saturn, discovered so much about the planet, also had a probe to land on its moon, the only moon in the solar system apart from our own.
Titan?
Yes,
Yeah.
so landed on Titan, the Huygens probe. But at the end of its mission, we can't leave a spacecraft to basically just orbit on its own without keeping track of where it is. And that's because if there is a potential of life somewhere, we don't want anything artificial that we've sent into space to either contaminate that or take life from what we kind of had on Earth and take it to those places.
But then the Huygens lander landed on Titan. Is that not the same issue?
Yes. So with the spacecraft itself landing on there, they would have obviously gone through robust testing, making sure it's as clean as possible. But the idea with that spacecraft is that they wanted to land it on the surface of Titan.
So they did that, but in a controlled way. They understood what they were taking there, rather than just
leaving it to do
something dropping down and smashing into the surface.
And it's not to say like the Cassini mission, the spacecraft itself didn't have those same kind of like ultra hygienic conditions in which it was manufactured and engineered, but at the end of its mission they just didn't want it to collide with anything else or cause any other kind of issues, and so they basically deorbited it into Saturn, which is actually really cool.
In a controlled way.
Yeah. On the way down, it actually was able to descend down through Saturn's atmosphere, so we get to learn a little bit more, learning about the planet as we get closer, but eventually it would have got crushed by the pressure.
I suppose just one more thing before we move on that struck me is we have things like Mars rovers that, although they're not in space, it feels like it's space for us. It's gone through space to get to Mars. They're still there, even the ones that don't work anymore. So 4 of them, I think, now on the surface. Does that count as space litter?
I'm thinking of like little Sojourner rover now, and I'm like, you can't call Sojourner litter. Like, I wouldn't class it as litter, but you're right. It's no longer working. It's there on the surface of Mars. Perhaps one day we can bring these spacecraft back to Earth. I don't know. They might become, something that we see in museums or somewhere like the Space Centre.
That'd be great.
But yeah, I'm not sure I'd call it litter. I don't know I'd go that far.
No, I think that's very fair. Okay, so we don't think there's much that we're leaving out in space inadvertently other than in Earth orbit.
Yeah, I think that's good.
Dhara, you take one. Let's give it a go.
Okay, so question we've got here. So this one is from Sean. And Sean says, who will dominate the space sector and acquire the most contracts for future missions to the moon and beyond based on the current climate of the industry?
Wow.
That's quite a hot
I
topic,
might be
isn't
looking
it?
to you, Roger. So you and Ed did an episode about private companies in space.
Yes.
One of those private companies led by a man that I was going to try not to mention this
You
episode,
can't help
but
but,
maybe,
yeah.
maybe I can. SpaceX is the one that immediately springs to mind as one of the most powerful operators in terms of private companies and working a lot with NASA. I think you and Ed talked about Boeing and why their attempts to take people up into space with NASA hadn't worked quite so well at this stage.
Yeah.
Any other thoughts?
So,
it's not an area I know a lot about.
No, I
admit.
think you've alluded to, some of the companies that we hear more so of in kind of the press and in the media. So SpaceX, notably the one that gets a lot of attention. There's companies like Blue Origin. So we also talked about the private tourist flight with Katy Perry on there. But there are lots of other private companies. And I think one of the important questions that is sort of asked within this is the idea of who's going to acquire the most contracts.
Yeah.
And
which doesn't have to be just human spaceflight, does it? I immediately went to human spaceflight. Okay.
But also, so this idea, when we're thinking about contracts, so we talked about Boeing Starliner, we've talked about SpaceX, and both of those are contracted by NASA to take astronauts to and from the International Space Station.
Yes.
When we're thinking about the moon, SpaceX and Blue Origin currently have contracts for a human landing system, so taking humans from lunar orbit down to the surface as part of the Artemis program. But there are many other companies that are contracted to do different things. So that's the sort of human spaceflight element. But companies are often contracted to do things like build scientific instruments and payloads, to build things like the landers. So Firefly Aerospace, Intuitive Machines, these are all companies that have landed on the moon as part of the private space program, but contracted by NASA, taking scientific payloads there. But I don't think that contracts are necessarily the only way forward when it comes to the new space race.
Because these companies might do things of their own volition?
Yes.
Okay.
So I'm sure Josh on a previous podcast talked about Rocket Lab. So they are, I think, a New Zealand-based company, and they have the ability in the sense that they make their own payloads or satellites. They also have their own rocket, which means that they don't have to be contracted by someone else to help with part of that. So they've got the ability to launch and to send their own equipment up into space.
So they can build the satellite, they can launch it, they can deploy it, operate it?
Yeah, so I think partnership's always going to have to exist, because we also need things like communication and ground control to make sure we're monitoring where these things are, tracking them. But I don't know that contracts are necessarily the only way forward, but they're a big part of, I think, how the space industry is developing. And I think going back to that human spaceflight element, one of the things that we're seeing now is a lot of companies talking about, well, if the International Space Station is going to be decommissioned in 2030, what are we going to put up there that allows that kind of human in low Earth orbit to continue? And so there's a company called Axiom Space that are looking at developing their own kind of space station for commercial purposes and other. And I know recently, I think it was Blue Origin has kind of signed some sort of agreement with, I can't remember off the top of my head who it is now, ESA or something. But the idea that Blue Origin are planning a space station called Orbital Reef, and ESA have kind of agreed that in the future ESA astronauts will be able to go there to perform activities. So yeah, I think the whole kind of nux of this question is, I don't know if it's so much, which private company is going to take the lead and which is going to dominate. I don't think that's where space should go, and it's unfortunate if it does end up that way.
So you're hoping something a bit more democratic, a bit more spread and diversified.
I think that's how you build competition. If you've got one person who's a front runner or one organisation who's a front runner, you're never going to get the competition and the drive to sort of one-up each other. And I think that's what drives space exploration.
Okay, this is from Sam. Okay, how far can we see into the universe, and do we think we're going to be able to see further in the future, or have we maxed out? That's a good question.
That's a good one.
So I mentioned earlier the James Webb Space Telescope in passing when we talked about the Vera Rubin Observatory. That's, I think, gives us the capacity to look as far as we currently can. And you, I think, will know better than me. I think the furthest we've seen is about 13 billion light years. Is that right?
Yeah, so we're seeing objects which are 13.23 billion years. We're teasing on the very edges of, or the very beginnings of our universe. And that's, galaxies that are very distant from us, that are receding and moving away from us. And that's dictated by the limitations, I guess, of the instruments that we're using. But when we think about, I guess, the actual observable universe...
Because the observable universe is the furthest we could possibly theoretically see, I think, isn't it, with our current technology. So if we ignore things like wormholes that might let us take shortcuts, it's as far as we could theoretically see? Or have I got that wrong?
No, along the right lines. It's as far as light has been able to travel during the lifetime of the universe. So physically thinking about the speed of light and how fast light is travelling over 13.8 billion years, how far will that light have been able to travel? And I think the current estimate for the size of the observable universe is something like 90 billion light years.
Yeah, I was going to say 93, so I think we're probably in the right
I'm
lines
hoping
there.
I'm getting the billion and million right.
I think it's 93 billion, yeah.
But that's kind of like the edge of the observable universe, in the sense that although things are moving away from us, there hasn't been enough time in the lifetime of the universe for that light to reach us yet.
Yes.
So the universe is likely bigger than that, but that is the limitations.
So there's definitely probable maybe, that there's stuff beyond the observable universe, but we couldn't possibly see it with our current understanding of science.
Yes, and kind of in like the expansion of that question is that going to get bigger?
Yeah.
Well, as time goes by, there will
Very
be time
gradually.
for that light to travel to us. And so the size of the observable universe will increase, but whether we have the capabilities of actually seeing to the very edges of that observable universe with the technology, the instruments we have, is a different question.
And so I think I'm right in saying that stuff towards the edge of the observable universe doesn't have to have taken 90 billion years to reach us, because when the light was emitted, because of the expansion of the universe, it would have been much closer to us. Okay, which is why theoretically we can see stuff that's further away than my first thought would be.
Yes.
Could be possible. I phrased that badly, but I hope it makes sense.
When we're talking about these galaxies that are 13.8 billion years ago, it's because we're looking at their light as it was emitted 13.8 billion years ago.
Which is the start of the universe,
that may not, it may not be the distance that those objects are actually at.
Yeah. So I think what we're saying is technology could improve such that we could see a little bit further, but the theoretical maximum of what we could achieve is going to expand very, very slowly along with our regular linear time. We're not going to suddenly be able to see twice as far for any reason.
Unfortunately not. And I think we've got enough of the universe to be exploring.
So we're close to maxed out.
Yeah, well, we've only explored a really tiny part of our universe. We look at our solar system, we've looked at parts of our galaxy, our local neighborhood, but there's so many parts of the universe that we haven't explored. Yeah, we got these pretty pictures of, thousands of galaxies, but really have we seen, the universe that we're capable of?
Yeah, I agree. We've seen such a small part.
Here we go. This one's a handwritten one. This one comes from Claire. What does space sound and smell like?
Okay. Well, my first thought is that there's essentially no sound in space. Sound requires a medium to go through. So material, atoms, molecules. It can go through solids, it can go through gases. So down here on Earth with an atmosphere, we can hear stuff. It's sound waves going through the air in our sort of regular way of hearing. In space, like the famous quote from Alien, the Ridley Scott film, in space no one can hear you scream. There's no material for those sound waves to propagate through. So my first answer is no sound in space. Is that literally true?
I would kind of agree with you in the sense that we're not going to hear the sounds in space, but where you've got, I guess, material that is close enough together that actually the whatever it is, gas or solid, and those particles can vibrate and pass along kind of the energy between them, perhaps there is sound. But for that to then propagate through the vacuum of space wouldn't be possible because, like you said, we need molecules to bump into the molecules beside them to pass on that sound energy. So while there may be sound in space,
we wouldn't hear it.
We wouldn't be able to hear it because I don't think that sound can propagate the distances between those objects. In my mind, I'm thinking about like a supernova explosion or something wild,
which would be loud.
where there's got to be material passing energy between each other, but we're never going to hear that sound get to us.
There's another thing that strikes me, which may be what the question is alluding to in this. I've seen some beautiful things over the years where people have, I think they call it sonification. They've basically turned radio waves or light waves coming to us here on Earth from space. They've adjusted that and made it into sound. So I've heard the sound of a black hole.
Sonification.
That's the
word.
That's what they call it. Good. And you get these kind of weird ethereal sounds, but it's all kind of shifted. It's taking the frequencies of visible light or whatever light, it might be infrared or whatever it is, and shifting it down to make it the frequencies that we can hear.
Yeah.
So that, although it's not literally what space sounds like,
it's an
it is often
interpretation.
presented, exactly,
Yeah.
perfect. It's almost like an artistic interpretation,
Yeah.
isn't it, to represent those waves coming to us in a form of sound.
I think there's also been the sounds of Mars. So I think some of the rovers on Mars have, through the very tenuous atmosphere, been able to capture some of the sounds of the planets. But that's not like being out in space. That's on a planet. That's on an object.
Planets,
yeah.
And you do have a material, a medium for that to propagate through.
Yeah.
Yeah.
How about the smells?
I was hoping you'd forgotten that, Hal. So here at the National Space Centre, we do run an activity sometimes called Smells of Space. And again, I think, well, if you were out in space, in what we might think of as outer space, again, I don't think you would necessarily smell anything. Though you would if there was a cloud of gas or a cloud of particles, you could smell that, because that doesn't need a medium to propagate through. If it happens to
come you inhale
it into your nose, you would smell it. We often talk about, I think I'm going to betray how long it is since I did this activity. I think we say that the moon dust, they reported, the Apollo missions reported that it smelled, I think, like gunpowder. There's one we talk about, there's a cloud, I think, of material, cloud of gas close to the centre of our galaxy, which we say smells a bit like raspberries.
Yes.
I think it's that we say there's a chemical in that cloud we've detected that is the same chemical we have in raspberries.
Yes.
You'd have to get a long way to get that to smell it.
Me and you are both. It's going to show that we don't do this activity enough. But I think the first point to make is, yes, things in space have a smell, but unless you're going to take your space helmet off and smell those things, you're not going to smell them.
Yeah.
So where you talked about the Apollo missions, it's not that they were out on the surface of the moon and smelt it.
They smelt it when they came back into this spacecraft, of course. Yeah.
The moon dust is really static, so it's stuck to their spacesuits. They come back in, they get out their spacesuits, and they have that lasting. It's a bit like my growing up, my household is just full of like curry smell, and once the mum starts cooking curry, like it's everywhere, and it's like that. It lingers in your clothes, and so they reported it as smelling like gunpowder. The smell of space itself, so astronauts who've been on spacewalks from the International Space Station.
I think I know this one. Is
What's
this the
that
one that's barbecued meat
there we go.
And some kind of metal?
Yeah, it's like seared meat and metal kind of smell. Yeah. And I think that comes
again, is
from
them coming back in from a spacewalk?
Yes.
Okay.
And I think that the idea is that although the amount of carbon in space is very low, I believe it comes from the sort of carbon-like nature of the element in space.
Okay, and you don't need much to stick to you to have at least a faint whiff of that smell when you get back into your spacecraft.
Yeah.
Okay.
So yeah, once it's stuck on there and you take a good inhale, you'll probably smell that. I know, and I can't remember off the top of my head the chemical, but I think it's the smell of raspberries and the taste of rum or something like that.
That sounds quite tasty.
Rum and raspberries. It was a great combination. And it's
we'd go to your house, have a curry,
and rum and raspberries.
That sounds delicious.
But it's basically a chemical that's found in a nebula out in space.
Right. Okay.
And I think one more that I remember is somewhere in the clouds of Jupiter, there is an element that smells a bit like marzipan, like almonds.
Interesting. That's kind of a bit Marmite, isn't it? Some people love it, some people hate it.
So there's lots of different smells, and those smells come from the different elements and the different chemicals that make them up. And we can learn about those through missions and spacecraft, and here on Earth as well, doing astronomy. And then we find out what chemicals are there, we put them together here on Earth, and then we can reproduce the smells of what it would be like.
This is what it might smell like.
Yes.
Yeah. In theory.
Yeah.
Okay. let's move on. I think we've got one question to go, so I'll take this one. Where are we? There we go. This is from Kaylee. This is a great question to end on.
I love the pause at the beginning.
Yeah, giving myself a few extra seconds. Where would be the best place in the universe to go on holiday? Now, I think we should ignore the practicalities of this. Okay. Otherwise, the answer is going to be very boring.
All right, you start, because I think you've got something in mind.
I gave myself a few seconds. I haven't, but I can. So, I mean, I'm fascinated by the planet of Saturn. I talked about that with Josh last time I was on this podcast. Beautiful. The idea of being on the surface of the planet, which, again, wouldn't be technically feasible because it's gas, or on a moon and looking up and seeing the rings above you, I think would be incredible. So I think that would be amazing. I guess it depends what temperature you like. Something very cold.
Yeah, but if you're near a spacecraft...
Yeah, we're forgetting the practicalities, aren't we?
Okay.
I immediately forgot my own rule. So we can adapt to all that. So I think Saturn would be very beautiful. Close to a nebula, I think would be really interesting. We've seen beautiful pictures from telescopes here on Earth, from space telescopes of various nebulae.
I hate to burst your bubble here, though.
Go on.
I feel like being in a nebulae would be like being in the clouds.
Oh, well, now this is you've kind of touched on what I was going to say, but I think you probably have taken it further, because I was going to say, we know that, I think it's true, isn't it, that a nebula, even though we see the beautiful colours and shapes, it's a cloud of dust and gas out in space. I think it's less dense than the best vacuum we've ever created on Earth. So even a nebula, not just the stuff in between, is incredibly the opposite of dense. Non-dense.
Not very dense.
So you were absolutely right. If you were very close to it, you'd see nothing. If you were closer than we are. So I want to get I want to see how close I can get and for it to still be beautiful.
Okay.
And whether you can get to a stage, you're absolutely right. If you went into the nebula, you wouldn't be surrounded by those beautiful coloured lights. But if you got closer to it, so you had a nebula that was much larger than we can see it on Earth.
To see it clearer and in a bit more detail.
But it's an interesting point whether actually we would never get close enough and still be able to see it in such a beautiful way.
Yeah, I'm sorry I kind of like rained on your parade
there.
No,
you come in, you fact-checked me beautifully. What about you? Any thoughts of where you might?
I feel like you've given me a chance to have a think about this, because having been asked the question of would you ever go into space, my answer has always been I would love to go into Earth orbit, just to be able to see our planet from above and just to see it with our own eyes for the treasure that it is. But if we're going a bit further out, I think I would want to do the same with the Milky Way.
Okay, yes.
Now
which you could see.
Yeah, I don't think we are ever going to be able to develop the technologies to go beyond our galaxy in the time frames that most of us are familiar with. It's 100,000 light years across at best, and we've not even left our solar system yet. But I think the galaxy is beautiful in the sense that you've got these lovely spiral arms, and again, it would be a scientific endeavor where we can confirm it's a spiral galaxy, but also in the halo, these like peppered globular clusters. And I think from some of the pictures we've seen, globular clusters are actually some of my favorite astronomical objects. So I think I would want to leave our galaxy and then just kind of, I don't know, float about my spacecraft and just like admire the shape, the size, the beautiful clusters of stars, and then possibly even see like the Andromeda galaxy in the distance somewhere.
So you could maybe have a very long holiday where you drift around just outside the Milky Way looking for the perfect spot to see all those things you want to see.
Maybe. Do you think I could leave my job at the Space Centre to do that?
I think if you could find a way to do it, they'd probably allow it as research.
No, I think it'd take, beyond lifetimes. It's a dream.
Good dream. Well, thanks so much for sending in those questions. We've certainly enjoyed having a go at answering them. I'm not sure we nailed all of them, but I think we gave it a decent attempt. Please do send in any more questions you have. We're intending to do quite a few of these mailbag episodes, so please send in any questions you have to podcast@spacecentre.co.uk.
And if you're looking for some stargazing challenges, then do check out our blog on our website. Throughout July, we'll have a number of different stargazing challenges for you to have a go at. So make sure you go out and have a look for some of the astronomical wonders you can find. And you'll find a link to our Stargazing Challenges blog and also link to the Vera Rubin images we mentioned in our Space Wows in the description below.
Thank you so much for joining us once again. If you do enjoy this podcast, please like it, subscribe, tell your friends, all the things that podcasts always tell you to do. It's really helpful for us. Thank you so much, and hopefully see you next time.